Hello, everyone. My name is Lee Chun, and we're going to take a look at Azure NetApp Files today in this session. So, according to research data, there are about 65% of workload that is still remain on-premise today. And out of all of those workloads that requires external file storage, about half of them are relying on file-based storage. And so for the applications that relies on these file-based storage, it's a challenge for them to move to the cloud because it's usually very difficult, if not impossible, to rewrite these applications with REST APIs or distributed system programming paradigm. It's very expensive for enterprises to move these applications to the cloud, so it's very important to have a cloud-side file service available. But if you take a look at the existing cloud file shares options on the market, especially for enterprise workload, the performance is suboptimal. So that's where the Azure NetApp Files comes into the picture. We are bringing NetApp, very high-performance file storage OS, into Azure. Now, for many of you, this is probably the first time you heard about Azure NetApp Files since the start of this conference. One thing that I want to emphasize again in this session is that this is a first-party service from Azure. What does first-party means? It means that you will have the Azure brand and credibility stand behind the service. It means that you can hold up the same expectation on the SLA, on customer support, on the sets of tooling from PowerShell tooling, from REST API SDKs. You can hold up the exact same expectation you have with other Azure services for this file service. You also will just transact the same way that you are already familiar with Microsoft. What that means is if you, let's say, if your company do sign enterprise agreement with Microsoft, the usage from the service count towards your commit. I'll take some Q&A at the very end if you don't mind, because I may not have enough time, as always. So the most important thing, being first party, though, is that we are actually hosting the NetApp hardware inside Azure DC. We are integrating the hardware into Azure network, the Azure internal network, physically and also software-wise. So this is not other solution that you may have heard of, the private hosting solution you may have heard of, where the hardware is simply located in a colo and you're just connecting through some kind of VPN pipe to do data transfer. This is not that type of solution. So what does it look like architecturally when I say the hardware is integrated inside Azure? Now let's take a look at a quick architecture diagram. From a customer standpoint, you as a customer, you can directly go to Azure portal or from your client app that program against our REST APIs for the service to request the NetApp resource. Now the portal or your client app would go through the ARM gateway, and which would turn around and ask for a new resource provider that we co-develop with NetApp, a NetApp resource provider. The NetApp resource provider, upon receiving the request, will start to do two things. One is it's going to talk to a NetApp service delivery layer, which in turn talks to the actual hardware to provision a dedicated tenancy on a HA pair, specifically for your subscription. And another thing that the NetApp resource provider does is turn around to talk to the Azure network resource provider, which also turn around talk to the Azure network infrastructure and start to provision a dedicated network path for your data volume. And the way we achieve this is by using a feature called virtual network ingestion feature from Azure VNet. Basically, in your subscription, you will have a VNet where you deploy the VM that you want to mount the volume to. inside this VNet, you carve out a subnet that you would delegate to the NetApp resource provider. And inside that subnet, Azure Networking is going to create a virtual NIC. And then this NIC becomes basically a gateway for your VM to communicate with the data volume on the NetApp hardware. So now we'll take a look at the demo, a live demo, not a live demo, a demo with this service. Once we're all done with pictures of the architecture. Yes, 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 great. You'll still get a chance later on in the breakout session to take more pictures. OK, so we'll take a look at a simple creation workflow demo. OK, so just like using any other Azure service, you can create NetApp resource directly from Azure portal. Currently, the service is in limited public preview, so it's only accessible through a special private portal. But the first thing we're going to do is we can look up Azure NetApp Files directly. And then here we are. OK, and the first thing we'll create is a new type of account called NetApp account. This is very similar to the Azure storage account. It is mostly meant for administrative grouping purpose. It is tied to a single region. We'll pick the right resource group here. And currently, the demo is running from a test location, but the preview is running in ECUS. So as the account is being quietly deployed in the background, a lot of stuff is happening right now. If you recall in the architecture diagram, this is when the portal is talking to ARM gateway, and in turn talk to the NetApp resource provider, which is then talking to the NetApp service delivery layer to secure a dedicated tenancy for this particular subscription. So the account deployment has succeeded. Now let's take a look at the account. Now, as you can see, this just looks like any other Azure resource. You can apply RBAC control over this particular account with the right role and scope. The next thing we need to create is something called capacity pool. This is a concept that is created to purchase pre-provisioned storage. Right now, we're only releasing a premium tier. We will release more tier, lower cost and higher cost tier in the future. And right now, the current minimum size of storage you have to buy is 4 terabytes. OK, so once we have a pool of pre-provisioned storage, now the next thing we'll look at is actually going to be the volume. So here's some properties of the pool. OK, so to create a volume is something you carve out from the pool. You can have many, many volumes inside the same pool. The volume is the unit where you get your quas. So we have a 4 terabyte pool, and right now we're assigning about a 100 gig of size for this particular volume. And we have picked a pre-provisioned VNet and a pre-provisioned subnet inside that VNet for this volume. So we're going to start creating. Now, right now, what's happening in the background then is, again, from the diagram, if you recall, it is the Azure Network resource provider that is creating a secure network path, creating a virtual NIC inside that delegated subnet so that you can have a secure path to talk to your data volume. And one more thing to know, when I say the quas is actually being provisioned at the volume level, right now we are, for premium tier, we are having a throughput of about 65 megabytes per second per terabyte provision. And so, for example, if you have a 2 terabyte volume, then you are set to see a 130 megabyte per second of throughput. And the quas is throttled to grow linearly according to the size you have provisioned, not the size you have consumed. OK, now we have the volume ready. This is where you can see an export path with the mount IP. But let's actually take a quick look at all the resources that we have just created. So here you can see the account, the pool, the volume that we just created. And you can also see the NIC that Azure Network Resource Provider created for you to access the volume. Here is the VNet. We're going to take a look at the subnet that we talk about as a critical step. So this is the subnet carved out from your VNet. It should be delegated entirely to NetApp Resource Provider. And at the bottom, you can see the delegation. So inside this volume, there's a mount instruction page where you can find the IP as a mount point. And this is the IP coming out from the subnet that we have just seen. OK, so that would be the oh, great. We also have more. We also have export policy that you can manipulate on these volumes. This is the level of access control we provide so far. You can manipulate. You can decide to which IP or IP range you want to give read or read-write access to this particular volume. We also support snapshot capabilities. It is already built in. You don't have to write separate applications to do snapshotting. We actually right now also support a restore snapshot into a new volume. All of these capabilities, you can see live demos over there in the NetApp booth, or you can come to attend a session, a much deeper dive session we have later on around noon at 12:30. A repeat of the same session would be available later on at 4 o'clock. So that will be the end of this session. Let me know if you have any questions. Yes. So the question is, I have mentioned this would be available for enterprise agreement. Would this be also be available for CSP? We do have the intent to make it available for CSP. Thank you. All right, folks, feel free to, yes. What do you mean by from the disk? There's no.
Yeah, but there's probably like SATA disk in the bottom. Is everything every time we access the data? Is it redirected from the SATA disks, or is it some kind of you have the possibility to have some kind of cache on a higher level for performance reasons?
I think that's no different from in an on-premise scenario how the NetApp storage array, if they internally already have multi-tier caching. That's what you would see here as well. But if you want to use an additional software-based caching into your service, it would also be similar, but it would not be serviced from this file service. Yeah, does that help? Yes.
Each volume comes to a subnet, or we can assign a subnet for different volumes. When you create a volume, you need a subnet.
I see. So the question is that I talk about there is a subnet you have to carve out and delegate to NetApp Resource Provider. Would it be possible to assign an individual subnet for each of the volume that you have provisioned? Is that the question?
Maybe we can assign one subnet for 2 or 3 volumes, or we need to consume one subnet per volume.
So regardless, it's actually the current requirement. You can only have one delegated subnet within that VNet. And all of your NetApp volumes would be within that single subnet. Actually, these volumes are going to, in most cases, share the same IP. So it's not guaranteed. So basically, you can consider one IP is tied to one NIC, one virtual NIC. And then we would try to let as many volume to share the same NIC as possible. But there is some behind-the-scene artifact that would exhaust at one point. Then we would produce a new NIC for the subsequent volumes. So you can kind of consider it's not exactly one-to-one mapping. It's not exactly one IP to one subnet mapping either. Yeah. Okay. So if you have any more questions, feel free to come on stage. But otherwise, I will turn the mic off. Thank you.